Well, 12:50 it is. Teach you I will. Mm.
How you doing? Good lunch? Good lunch. Yeah. Lox. Salmon, we call it. Salmon in the States. Some people say salmon, but I say salmon. Anyway, it was good. Pardon me. Pardon me. Pardon me. Pardon me. My name is Carl Franklin. I'm going to be talking about transient error handling in all of your connected systems. Anything that uses HTTP client is potentially flirting with disaster, especially if your network goes down or the service that you're calling is down or you've got local network problems or Azure is down or AWS is down. We don't really think about these things as developers because if it doesn't work, it doesn't work. The user just goes away. That's all fine and good for desktop software and mobile software. Oh, it doesn't work. I'll try later. But what if your software is in the cloud? What if it's a service that's calling another service? Nobody's there to go, right? So you have to know how to deal with those problems. So that's the problem. There's all these connected applications. So Poly is going to help you deal with this. But first, let me talk about my company, AppvyNext, just a little bit. This is a consulting company, and we don't have a lot of business, but we just generally operate on word of mouth. I basically send an email out to all the listeners of .NET Rocks. You know the show? All right, cool. And I said, hey, anybody interested in working with me? And a bunch of people replied, yes. So I interviewed some, and some went away, and others stuck around. And the ones that stuck around, we started a Slack channel, and we started juicing back and forth on various techie things. And some of those people went away, and I was left with this core group of people. So we essentially are the shepherds now of the Poly project. So that's why I bring it up. If you go to GitHub and look for Poly, it's under the AppvyNext GitHub repo. So we, meaning Poly, got into the .NET Foundation in October 2016. That's very cool. It was a very good honor for us. But more history is coming. So these are the transient errors that can happen. As I said before, outages, your network's down, their network's down. But denial of service attacks is an interesting one too, because you wouldn't necessarily know if the network is down or if it's just swamped. IO locks don't happen all that often, especially with good stuff going on in the back end. Connected device failures like IoT devices, okay, that could be part of it. But the big one is the network is down for whatever reason, and somewhere between you and where you're trying to talk to, there's a router that just went. So what happens when you flood a struggling service with requests? Perhaps a denial of service attack. But how does that actually happen? Well, check this out. I don't know if you ever saw I Love Lucy, a show from the 50s in America, but Lucy and Ethel got a job wrapping bonbons. And they come down a little conveyor belt and everything's good, but then they come a little too fast. And oops, I missed one. Oh, what am I going to do with that one? I can't just drop it, so maybe I'll just throw it in my mouth, maybe throw it over my shoulder. I don't know what I'm going to do with all these problems, so yeah, hilarity ensues. So remember that image of the ladies wrapping chocolates. So here's Poly. All right, it started in .NET 4.5. It's all in .NET 4.5 plus, .NET Standard 1.1. That means it's also .NET Standard 2X and every standard higher than that. You get to fluently express transient policies, right? Using patterns that you probably have heard of before, like retry, circuit breaker, timeout, bulkhead isolation, and fallback. There's the GitHub repo right there, or install package Poly. It's kind of easy to understand, easy to remember. The little poly bird right there, it doesn't have anything to do with parrots. It's really poly stands for policies, and policies are at the heart of what we're getting after here. So these policies come with a bunch of different resilience strategies. And the retry strategy is, well, maybe it's just a blip. Maybe if I wait a little bit, that'll change. A circuit breaker is sort of like the next level of severity up. You could say, well, that system might be down or struggling, so I'm going to stop sending chocolates down the line so Lucy and Ethel can catch up. Essentially, that's what that does. And the timeout is the strategy of, hey, let's not wait forever. We can't just, maybe after an hour or so, or a half an hour even, we can give up and say, nope, this is not going to happen right now. Come back later. Caching, pretty obvious. You can, reply with something that's cached if the network is down. And a fallback is, that final message that says, look, I tried, it didn't work, it's not going to work right now. But instead of throwing an exception that some log might log reader might find unreadable, you can actually compose an exception message that is more appropriate. So that's your fallback. So here's the history of Poly. In 2013, Michael Wolfenden invented it. And in 2015, Scott Hanselman started talking about it. ThoughtWorks started talking about it. We started talking about it on .NET Rocks. So it became quite popular in 2015, or it started to get popular. In December 2015, AppVNext took stewardship. We added all this stuff, async support, the advanced circuit breaker, other features, and deep integration into .NET Core 2.1 came in 2018. So in .NET Core 2.1 and higher, if you use the HTTP client factory, then that is using Poly. You can specify the attributes for policies right there. And yeah, so .NET Core. I had a problem. I used Java. Now I have a problem factory. Dum, 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 dum. Okay. So check this out. Poly adoption. Look at 2015. That's where it actually began to get popular. And it just skyrocketed. So this is a free tool set, right? I mean, this is not anything anybody's selling. But the cumulative downloads for all packages to date is over 29 million. That's crazy. Woo. All right, so here's how it works. The first thing you do is define a policy, and it's fluent, as you can see. Here's my policy. We're going to handle this particular exception, and the policy is actually going to be a retry forever, asynchronous policy. This is just a simple example. So you define what errors you want to, or exceptions you want to handle. You can handle all exceptions. There's a whole bunch of options there. And then what strategy you want to use for this. And then step 2 is to execute code using the policy. So you're essentially using the policy and wrapping all of what your code is into that. So if it's a block of code, or if it's a method or whatever, an action, a func, doesn't matter. You do something within the context of the policy. All right, so let's go over the retry strategy patterns. So there's just a single retry immediately, and you can specify a number of retries. There's a wait and retry, which has a little timeout between each retry. And then there's retry forever, which just keeps retrying without any kind of cancellation forever. Now, you might be asking, well, that's kind of silly. That could just completely lock up my application. There are times when this would be acceptable. I was actually working on a WPF app that was gathering data, live data from a Connect. And then it would send that data up to the cloud, which would do the secret calculation sauce on that data, and then bring back the results, in forms of scores and all of that to the user, which was a critical step in a process. And so if that data didn't come back, we couldn't continue on to the next step, right? So it was either you wait forever and allow the user to decide when they want to, kill the app, or go check the network, to go check the Wi-Fi, whatever, or it wasn't going to run. So it was either going to run or not. So the circuit breaker is a really popular way to handle retries, or to handle transient errors. So this pattern we didn't invent it. It's a pattern, but the ladies in that video are the downstream system. So they're the service that you're calling, right? And they're having a meltdown. So you want to give them a break. So stop sending chocolates down the line for a while so they can recover and catch up. Because if a downstream service is down and all of the calling, all the callers in the world are knocking on the door, boom, 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 boom. Now you're creating a denial of service attack. So the thing's never going to recover if you don't ease up a little bit. So that's what the circuit breaker does. It allows calling code to stop for a while, right? But remember, these are policies. You're going to set it and forget it. You're going to say, just go ahead and get me the results of this query, or of this REST action, or whatever it is. And the policy takes care of everything. So if it retries for a while and then it decides, I'm going to break the circuit, those retries will fail while that circuit is broken. And then when the circuit closes again and all electricity is flowing, so to speak, then it will try again. But this is a really cool idea, and certainly not unique. The timeout, obvious what a timeout is. Hey, after a half an hour of doing all these other policies, just fail, just time out. So you can use an optimistic mode with a cancellation token so that you can cancel it at any time. Pessimistic mode returns the caller even when that delegate doesn't support timeouts or cancellations. So, and you can use all these things together, obviously. You wouldn't choose one or the other necessarily, just as a single policy. So bulkhead isolation is a really interesting idea. The source of this metaphor comes from a large ocean vessels, big ocean liners or ships that are susceptible to, let's say, torpedoes. And we don't want to just have one big open hull, because a hole anywhere in the hull could take down the whole ship. Titanic. Sorry. So you get what I'm saying. So what they do is they design these hulls with compartments, and they're called bulkheads. And so a torpedo could hit a particular bulkhead, and that bulkhead would fill with water, but it wouldn't affect the rest of the ship. So the whole idea is that one problem connection shouldn't bring down the whole ship. And here's the scenario. You've got a service out there that's calling downstream service A, downstream service B. All right? The calls to service A are working just fine, but the calls to service B start failing. Well, what happens is that code and all of the resources in that code has, whether it's memory, CPU, whatever, get used up on the squeaky wheel, right? On the one that is got the problem. All the retries are happening there. So that's starving resources away from the calls to the service that isn't failing. All right? So what ends up happening is that you don't get anything from either of them, or you get very few from the one that's not failing, and you certainly don't get any from the one that is failing. So the bulkhead policy allows you to separate those calls into bulkheads. And you can think of them like threads, right? Rather than just having one thread where both of these services get called, you have one for each, and so they operate independently of each other, and they have their own resources. So that's sort of the analogy. Another analogy is the express line in a supermarket. If you didn't have an express line, then people who only want one or two items, or less than 12 items, would have to wait in a long line and never get out. But once you introduce that express line, then everything flows much more smoothly. The cache or the read-through cache, I just want to iterate that Poly isn't a caching, it's not a cache provider, but what it does is it lets you plug in your existing cache provider. So memory cache, Redis, Elasticache, whatever it is. So it's just a place where you can access data in your cache. And fallback, as I said before, how you respond with the final, I'm sorry. Policy wraps combine any of these policies together in a single policy. So you'll see in the code, in the demos that I'm about to do, where you can have multiple policies. So you essentially, in your outer policy, you execute async and you got a block of code, and then you can have another policy that executes and then nest them, okay? And so they can work together like that, but it produces really messy looking code. So the policy wrap is a way to put all of those things together into a single policy that you can execute one block of code with. That's all that is, just a little syntactic sugar. And poly is just syntactic sugar anyway. It's really, if you look at the source, it's really just a big wrapper around try-catch. That's pretty much it. It's all syntactic sugar. So to recap the basics of policies, you define how these exceptions should be handled, what exceptions should be handled. Policies are fluent and concise. They're thread safe. They're reusable because they're just objects. You have synchronous or asynchronous versions of all of them. You can chain them all together and apply to any action, function, service call, code, anything at all. All right, so now let me show you the demos and we'll get back to this in a minute. I have to do that. Okay. All right, so there's two parts to the demo. One is this test app, which is a web API application. And you can see that's running right here. It's just a web API application. There's an interesting little tool that we wrote called the throttle store. And this throttle store we configure with a number of requests we're going to allow in a time span. So within 5 seconds, we're going to allow 3 requests. And any requests that come in after the third one, within 5 seconds from the first, will return a 500 error. Okay? So that's config number 1. Config number 2 is the web root. This is in the client, right? So this is essentially saying to the client, we want to use this. This is our API endpoint. There's also a deployed API endpoint if you want to test it, polytestapp.azurewebsites.net. All right, so the second part of this is the client. And this is just a console application. And we have a whole bunch of different demos here that are all based upon the same idea. These are the synchronous versions of them. I'm going to go through the asynchronous versions of them. So the first one has no policy, and I'm going to just run it first, and then we'll go through the code, and I'll show you exactly what it looks like. Nice, 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 nice. Why that? Why that? Why that? You should be running. Let me go ahead and run this guy again, the server. Oh, probably because the server wasn't running. You know. All right. Here we go. So the good responses come back in green. The failed responses come back in red. And it goes over and over again. So I'll press my space bar, gives you some stats. The total requests made, 7 succeeded, 14 failed. All right, so we got a response. Pretty simple. Now that you know what that looks like, the other thing I want to just show you on the server is I'll just stop it here. So the actual controller itself, the values controller, it's just simply when we pass an ID, it's returning response from request number ID. So that's all there is there. Okay. So let's take a look at what this code looks like. And all of the demos are going to follow this same exact pattern. All right. So we have our execute async. We have an HTTP client. We're counting total requests and adding them in each time. We do a try catch here, and we call get string async on the values with the total request, which again updates every time through the loop. If it works, here's our response in green. If it doesn't work, our response in red. And then we wait a half a second and we keep going, and some statistics. So very, very simple. Okay? So now we're going to add a little bit of a policy here. And again, this isn't guidance. This is a demo that shows you what these different policies do so you know what to expect. So this is a particular policy called retry, and we're not going to wait in between the retries. We're just going to retry 3 times, all right? So we specify 3, and this is the policy itself. We say policy handle any exception, a retry async 3 times. Here's our exception and our attempt. So essentially, this is your new exception handler. Tell them what they want. All right, so we're going to display these messages in yellow so that you know they came from within the policy. Okay? And then we up the retries. Now we have our try catch, but now instead of just calling the getString async, we do a wait policy execute async, and then all the code that we want to run. Okay? So notice that, you know, this isn't inside the try catch. This is in the policy. Your handling code is in the policy itself, and that is all that is all just available as an object. It's pretty cool. All right, so let's try this. Boom, boom, boom. Wham! 3 attempts, 3 retries, and then we fail. 3 immediate retries, and then we fail until 5 seconds is up. Okay? The next level of intensity is wait and retry a number of times, with probably 3 times as well, with a wait in between. Same exact configuration here, except now our policy is a wait and retry. Retry count is 3, and we're going to wait for 200 milliseconds between each retry. Otherwise, this is all exactly the same. It's just the definition of that policy that's different. So those 3 yellow reports come 200 milliseconds apart. That's all you're seeing there. That's the only difference. Okay? All right. Let's up the ante a little bit here. This is a wait and retry, same number of times, well, not same number of times, same timeout, with enough retries so that it actually works. So here we bump the retry count up to 20, still waiting 200 milliseconds in between each one. We're just going to get a screen full of yellow, and then we're back to normal. Okay? Shouldn't be a surprise. Obviously, that's magic numbers aren't good. So here's the wait and retry forever, which instead of having a number of tries, only has your duration, but it's just going to keep retrying and retrying. So the output from this is going to look exactly the same as when we specified we wanted 20 calls. Okay. All right, now this is the coolest one, I think. This is a wait and retry with an exponential back off. So exponential back off means that the timeout is going to increase exponentially by a power of 2 every time we go through the retry process. So it's going to be a quick retry, then a little longer, twice as long, twice as long, twice as long. And this is a really good pattern to use when you're doing retries. Yeah. Okay. So this is essentially a wait and retry async. You can also do it with wait and retry forever, but we know that 6 times is enough. So that's why we did it that way. All right, now we're going to start nesting them, and you'll see why the policy wrap is a good idea. So we're going to nest a wait and retry with a circuit breaker policy. So we'll have 2 policies. Some nice comments up here too. And these samples are all on GitHub as well, so you can just run this stuff and go through it yourself. So we have 2 policies. The wait and retry policy, we're showing also exception filtering here, that if we don't retry and the inner circuit breaker judges the, we don't retry if the inner circuit breaker judges the underlying system is out of commission, right? So if it's not the broken circuit exception, otherwise all exceptions. Wait and retry forever, 200 milliseconds. And now we have a circuit breaker policy. And the circuit breaker, like I said before, it's a little, the open and closed for circuits is a different metaphor than you might be used to database connections. When a database connection is open, you can access the database. When it's closed, you can't. But a circuit is like a circuit of electricity, where when you close the circuit, electricity flows through because it's making a loop, right? A circuit breaker opens the circuit, and so electricity can't flow through. So it's a different metaphor. It's exactly the opposite of a database connection. So when the circuit is open, it's broken. When the circuit is closed, it's working. So we're going to allow 4 exceptions before breaking the circuit. We're going to break the circuit for 3 seconds. And now we have some lambdas for what we do during the delay, on reset, and on half open. So when we're delay, we say breaking the circuit for this number of milliseconds, and these are going to be in magenta because we have to have a different color. The next one is going to be half open. So half open is after 3 seconds, we're going to test a call. We're going to make one test call. And if that works and goes through, then we reset. We close the circuit again. So now check this out. This is what the nesting does here. So we're with the wait and retry policy on the outside, like the outer loop, we're doing the circuit breaker policy inside. So, right, wait and retry, execute, circuit breaker, execute, and then the actual code, which is the same exact code. So notice that your calling code is very, very simple. All the handling goes in the policy. All right. All right, so that's one complete cycle there, green to green. So what happens here is you've got that you have the what am I trying to say? The timeout. Then we break the circuit, and we break it for 3 seconds. During that period, you've got fails. You've got real exceptions that are failing because the circuit's broken. We're not allowing those calls to go through. And then the next one is a trial. After 3 seconds, circuit's closed again, and then we move on. The only ugly thing about this is the nesting code, especially if you've got multiple, more than 2. So here we're going to do a wait and retry nesting circuit breaker using the policy wrap, which can wrap those 2 policies together. So here's our wait and retry. Here's our circuit breaker, exactly the same, except now we're making a policy wrap wait and retry on the outside, circuit breaker on the inside, outside to inside. That's how it goes with Policywrap. And now we just have policywrap.execute async instead of nesting those policies. Very simple. Output should be exactly the same. There you go. All right, just a couple more. This one is also using a fallback. So this will be 3. Actually, we have 4 policies. A fallback for each one of those other policies. So here's our wait and retry. Same exact. Circuit breaker, same exact. Now we have a fallback for the circuit breaker. And we have a fallback for any exception. So this, the fallback value is essentially the message that we're going to send. Please try again later. Message substituted by fallback policy, just so that you know it's coming from that. And this is going to be read as well, just like exceptions. Right? And there's the exception message. And for any what am I trying to say? For any exception, the fallback is a little bit different, but it's still the same, still doing the same thing. Now, here's 2 policy wraps. The resilience strategy, which is the non-fallback stuff, wait and retry, and circuit breaker, just like before. And then we're policy wrapping the policy wrap. So fallback for any exception, wrap the fallback for circuit breaker, and resilience strategy at the bottom. So resilience strategy, fallback for circuit breaker, fallback for any exception. Just showing that you're getting this fallback, nice little message. There you go. Okay. Pretty easy to understand. Now, this one illustrates where timeout comes into play. So this is a policy wrap including a fallback, a timeout, and a wait and retry. So the wait and retry timeout, or the wait in that, is deliberately so long that the timeout policy wrapping it will time out before it is done. So we set a very short timeout on the timeout policy itself, but then we're calling a wait and retry with a longer timeout because we've set that timeout on the outer policy. It's just going to say, all right, you've had enough time. And just so that we can demonstrate it, we've set it to a really short value. So here you go. Here's the timeout policy. And we have a couple of things here. On an abandoned task, some messages if it's canceled or faulted. We have a wait and retry policy. We have the fallback for the timeout, fallback for any exception, and wrapping the whole thing. Any exception, fallback for timeout, timeout policy, and a wait and retry policy. Now, the one thing that I probably glossed over a little bit, but was this right there. The timeout value is 2 seconds. So that's a lot shorter than the wait and retry policy, which is going to be set to 4 seconds. So what happens here is after 2 seconds of retries, boom, timeout policy kicks in, says, no soup for you. So again, not prescriptive, just saying the timeout is there typically for longer timeouts. You know, you decide how much time you want to wait in general with all of your policies before giving up. All right, so now we'll do the bulkhead demos. So remember I said the bulkhead separates a hull into multiple compartments. So when one gets torpedoed, it doesn't take down the whole ship. So that's essentially what we're doing here. And I have 2 demos, one with no isolation, and then the other one with bulkheads, and you can see the difference. So we have another endpoint on the controller, we have a non-throttled good endpoint, and then we have a non-throttled faulting endpoint. Non-throttled means it's not going to cut off after 5 seconds, 3 requests. It's just going to let you keep hitting it. But one is faulting and one is good, okay? So essentially we're going through a loop and we're randomly choosing either good or faulting calls. And then based on that, we're calling either the good API or the bad API, the one that is failing. Okay? And then we just have try catch and it shows you the result of that. I'm just going to let this go for a bit. You can see already the good endpoint failing. Faulting endpoint is obviously failing. All right, I'll stop it here. All right, so good endpoint requested 34, only got 4 good calls back. That's like not good, right? Most of them failed. The faulting endpoint, all of them failed. None succeeded, and there were some that were still pending. So obviously that's not going to work. So now let me show you what the bulkhead looks like. So we have a bulkhead policy for good calls and one for faulting calls. Just separating those into 2 different things. Now we're still making random requests, to either good or bad. But in the good one, we're making with bulkhead for good calls, execute async. And in the bad one, bulkhead for faulting calls, execute async. But the code is exactly the same otherwise. Now you can already see what's going on if you're looking at good endpoint succeeded. Right? All the good endpoint requests succeeded, and the ones that failed. They're either failed or pending. So there you go. Nice stuff. All right, I am now going to switch back to my PowerPoint. And pick it up where I left off. Okay. So some other features that aren't covered in those demos. We can handle multiple exception types in one policy just by adding or with .or. SQL exception, we can filter it to the number, for example. .or, this exception, that exception, whatever. Kind of nice. You can handle both exceptions and return values. So if you have HTTP REST endpoints that always return a 200, even if the data that you're getting is invalid, you can check the status code of that. So handle an HTTP request exception or the result where the status code equals whatever, internal server error. You can handle inner exceptions natively. You can handle HTTP request exception or inner operation canceled exception. A lot of flexibility here. So the policy registry, in some applications it can be useful to reconfigure policies dynamically without having to restart the process. So for example, you might want to tweak circuit breaking thresholds to be more or less sensitive according to the conditions in production. So the policy registry, you just replace the policy in the registry with a new one. And when the underlying configuration source is detected to have changed, it just news up a new one. So this is all on the wiki. If you want to know how to do that, I'll show the URL for that in a minute. So .NET Core 2.1. This is how easy it is. You just add in your startup an HTTP client service, and you can add a different HTTP client for each endpoint that you want to handle differently with different policies. So in this case, here's one for GitHub. we want to add transient HTTP error policy, wait and retry, async 3 times. And so that comes right into your HTTP client automatically. Very cool. This is new in 2019. SIMI, chaos engineering. So you can selectively inject failures into your code. So this is just a good way to test what's going on, what happens to your code when there are errors. So here we're injecting a socket exception 0.5% of the time. Turn it on and off. SIMI, yeah, it's a good name. You can also inject latency. So here's a 2-second latency, or you can randomize it, of course, 2% of the time. And you can also fake failures. So you can fake a bad request just to test your handling of your policy code. So here's just the place where you can go get SIMI. It's a separate repo. It's very cool. Let me put that back if you want to take a picture of it. Okay. So we also have a distributed circuit breaker because, you know, serverless functions and actors are inherently stateless, short-lived, so they can't maintain circuit stats, like how many calls have failed across calls. And they often exist in multiple instances, horizontally scaled, so they need to store and track the circuit store externally. And that's what this distributed circuit breaker is. It's a state store, which is using Azure Durable Entity Functions for that. So there's a couple other projects that aren't Poly that work, one on JavaScript and one on Java and Scala on the JVM. Poly-JS is for JavaScript that has retry and retry wait in it. I don't know the status of this. I'm not really a JavaScript developer, but you can go check that out. And then the Java one was a Netflix thing, but Hystrix is a robust resilience framework by Netflix, no longer in development. So I think it was early 2018 when they decided to end active development, but I'm not sure if it's being worked on by somebody else now, but there it is. Just, you know, here's your JavaScript code syntax. It kind of looks as you'd expect for JavaScript. And Hystrix, if you've done any Java. So the Poly Wiki, this is where you can find all the future stuff, all the stuff we're working on, questions that we want to ask the broader community, some extended documentation and configuration, some guidance, different patterns and unit testing strategies. It's a good place to hang out if you're really into Poly. And of course, we want you to contribute to the Poly project. Here's a Slack channel and our blog. And of course, the Poly repo right there. So the people that worked on this, I started with the demo and the API and all of that stuff. I started that whole project. Joel Hewlin came in. He did the throttle handler. But Dylan Reisenberger really took on a lot of the work once AppV Next really took stewardship of it. Dylan Reisenberger is a really extremely brilliant guy, and he lives in England. So, and there you go. We're getting out early. Does anybody have a question? No? Is it Scotch o'clock yet? Okay. All right. Well, thank you very much. Appreciate it.